Hi, hello, good morning, everybody. Thanks so much for being here after incredible nights out. I think that Australia has been really nice, and I think we are enjoying many interactive talks and a lot of great dinners. First, before I introduce the panelists, I'd like to tell you about that. It's exciting to be moderating this panel. Sustainability in Earth and in space has been this year's ISC's main focus, so we're happy to be able to elaborate a little bit more into that. And as we've been seeing during this week, space is already one of our most powerful and for sustainability assets on Earth. We use satellites to monitor climate change, track emissions, manage our natural resources, and also to respond to disasters. But also we're thinking about space sustainable. So not just how sustainability is being aided by space, but how we can make space sustainable. So this is also very interesting, how the activities around our planet are needed to become sustainable. We're having more and more satellites, we're exploring more, we're having more players, so it's important for us to know what's up there and how we can use all of this in a much better way. The priorities on the space sector, the maturity, geography, and also the diversity are very important. We have different countries with different priorities, different needs, and this is why we think that this panel is going to be very important to attract different points of view and also the different priorities. And with that, we're very lucky today to have different perspectives from different regions and space economies. So please help me to welcome to our panel, first of all, Enrico Palermo, our host. He's the head of the Australian Space Agency. Please give him a clap. Please take a seat. After that, I would like to introduce Dr. Gay Jane Perez. She's the Deputy Director General for Space Science and Technology of the Philippines Space Agency. Now, I'd like to introduce Benjamin Alvin Drew. He's the Director for NASA Space Sustainability. And last but not least, I'm very happy to welcome my boss, Dr. Joseph Aschbacher, the Director General of the European Space Agency. Perfect. So as Christian has already reminded you, we will be using this panel as also a way to interact with you. So we have a Slido. Please scan the QR code, and if you get any questions, shoot them to us. So we have a tablet here that's been dedicated for us to check it out. But before you start, I would like to warm it up all. So let me ask a couple of questions to the panelists first. So I will start with the first part, that it is regional sustainability. What are the challenges and the drivers that we get here? And despite many commonalities that we had across countries and regions, Space Agency also have a range of diverse ways of thinking. And I would like to start first with our host country, Enrico. Australia is 6 years, I heard about the Australian Space Agency, but also how we were reminded in the opening, Australia is actually very much involved in space for, I will say, thousands of years. So I would like to understand what is the focus on sustainability that is being driven by Australia?
Yeah, thanks Heriberto, and good morning, everyone. I think where we start when we think about sustainability of space activities is, we cover through this Congress the criticality of space assets. So how do we preserve access to space for future generations? If you think about critical infrastructure on Earth, we put in place mitigations, we put in place protections, we minimize random events potentially impacting that critical infrastructure. That's not the case on space yet. So very much a focus on preserving access and protecting the critical assets for Earth imagery, GPS, and all the services we rely on. So that's sort of number one. Another one is Australia, because of our landmass, we're very fortunate, it's a very large country, very large flight information regime. We see more than our fair share of debris re-entries. I think we've been looking at the stats, and over the period 2021 to 2024, we saw a 4 times increase in the number of predicted debris re-entries over Australia compared to the prior 4 years. And that shouldn't be a surprise if you look at the rate of launch. We've had some very big debris impacts. We had a few large sections of a Dragon crew trunk section from a Falcon 9 land in the Snowy Mountains in a farming region, and if that had obviously landed in a populated area, it would have been a great concern. We have debris washing up on our beautiful beaches, often COPVs, the carbon fibre structures tend not to burn up. So we're impacted, particularly because of our geography. The third relates to our science community. We're a proud astronomy nation. We're a key member in the Square Kilometre Array with the low antenna site in the centre of Western Australia, selected as a radio quiet site, but increasingly there is no radio quiet sites on the planet, also optical astronomy as well. And then the fourth, briefly, is cultural aspects. We've talked a lot about Australia's First Nations connections to the stars. Often in the stars and how they interpret them, it's the spaces between the stars that are significant, like Emu in the sky, is really the dust clouds in the Milky Way. And now we're seeing, it is transited very frequently by lighted objects, and that has cultural impacts. So I think they're the sort of 4 areas we think about why sustainability is important.
Oh, perfect, thanks so much. Now, Alvin, let's move a little bit to the United States. In the context of the renewed plans that you have to explore the moon, Mars, what is driving U.S. priorities when it comes to sustainability?
As you said, everything we're doing right now within NASA is to enable us to explore. There's an old saying out there, though, that getting to low Earth orbit, you're halfway to anywhere else in the universe, and we take that quite literally. We're using Earth orbit as our jumping-off platform. You see our International Space Station. We're partnering up with others to go do that, and this is a place from which we will depart to the moon, Mars, and other destinations out there. So our first duty right now is to operate safely in Earth orbit. That includes things along the lines of space traffic, so we don't, collisions of active payloads out there. Also debris, not leaving debris up there that we might run into, but also not having debris that we will rain down on places like Australia because they're our friends. And so once we can operate safely in Earth orbits, it's all the places where NASA has to operate, and we aren't limited simply to Earth orbit. We are going to the moon. We are presently at the moon. So it's doing the same things there. And so it's a case where if I had a time machine, I could have gone back 6 decades and told people what space around the Earth looked like in 2025, what might we have done differently back in the 1950s and 60s. Well, can we do those things differently now around places like the moon and Mars? But they also offer their own independent challenges. So how to, again, what are the first principles and how do we go about achieving those pieces right now as we have to think about those more seriously as we start to proliferate in orbits above the moon and Mars and on the surface of those planets as well, too.
Oh, perfect, thanks so much. I'm going to go now to Jane, to the Philippines. The Philippines is one of the world's more climate vulnerable nations. It relies heavily on satellites for data disaster management. Actually, you were discussing something about that with Joseph just before the panel. And the country obviously needs a space, but also it represents a risk. And from your perspective, what are the main challenges that make sustainability a priority for Philippines?
Thank you, Roberto, and good morning, everyone. The Philippines is rich in natural resources and a mega-diverse country. However, we are also consistently ranked as one of the most disaster-prone countries in the world, with typhoons, flooding, landslides, volcanic eruptions, and earthquakes. We just had a huge one the other night, causing huge toll to properties and lives. And with the changing climate, this just makes us more vulnerable. So space sustainability, our interest on that, is driven by necessity, the need for accessible, reliable, and timely space data that helps us in planning, decision-making, and effective resource management. And as an emerging space nation, we see that it's vital for the present and future generations to keep space safe and secure, not only to meet our sovereign requirements for data, but also to ensure that continuity missions that have generated decades worth of data remains available. So space sustainability is also driven by our need to mitigate risks from increasing space activities. Although we are not a major space debris generating country, we are affected by space debris reentry or rocket launches debris. Just this year, the Philippine Space Agency has issued 8 warnings on possible drop zones within or near our archipelagic seas. And we have documented and recorded fishermen's or Coast Guard encountering and recovered large debris. Just 2 months ago, we had an incident where rocket debris was sighted at busy time. It's like 6:30 in the afternoon, and people see it passing over, and there are sonic booms heard, vibrations felt. So it really affected the community. So we advocate for increased transparency, coordination, and maintaining responsible behavior for space.
Thank you, Ian. Joseph, Europe has been a global pioneer when it comes to environmental regulations, from the beginning of the Kyoto Protocol to regulations of the European Green Deal. Also, Europe is the continent that it is warming fastest than anybody, twice as fast as other continent. How does it all influence how ESAs perceive space sustainability?
Yeah, thank you. So first of all, very nice good morning here. I'm very happy to see such a full room. It shows also that space sustainability is a big topic and is of interest to everyone. Certainly also in Europe. As you said, Heriberto, we have policies in place that really are focusing on sustainability. It is sustainability of our planet, of the European continent, countries. Climate change is one element, but it goes way further. What do we do in ESA? The European Space Agency has developed a number of activities, and I start maybe in-house first before I go out to space, and because space is shared, and it's probably sometimes easy to say everyone should take good care of space out there, but we have to really start in-house in our own buildings, in our own front yard, in order to really practice sustainability and build it up. So what we do, I've decided in the European Space Agency in a document called Agenda 2025 that I'm committing that ESA, together with its member states, we are having a decarbonization of our footprint, of our carbon footprint, and by minus 46.2% between 2019 and 2030. So this is a value that is enshrined in our goals, in our objectives, and we're doing it. We are looking into the usage of electricity, having solar panels, for example, to produce solar-based energy, and so on. So there are many, many measures. They have to do with managing buildings, but also energy consumption. One of the large energy consumers, obviously, is our launch base in French Guiana, Kourou. So we have really looked very seriously into this, and I can tell you that we are on the path to reduce our carbon footprint significantly within the premises of the European Space Agency. We also work with our member states and industry because a lot of the activities we are doing together. So also we have life cycle assessments. We have issued a charter that was signed up by many of our members on the sustainable use of space in general. It's a very popular activity, and I can tell you that we have a lot of activities, working groups where we are working along this line. Then you go a bit further. We have satellites that are looking at our environment. We have one of the largest Earth observation monitoring programs, not only Copernicus, which is probably the best known, and I know the Philippines are working also with this data, but also everyone around the globe. Copernicus obviously is made to monitor our planet. We are disseminating large amounts of data to the globe for free as a service really to the global community in close cooperation with the European Commission. And this is something that I think Europe can be very proud of, to really assist other countries, all the nations to utilize this data. And they're not only for climate change. They're really for many other purposes as well, from agricultural management. You can actually use many services to create businesses and really make money based on satellite-based information and make sure that this is well utilized. We also have an Earth Science program that goes very closely with climate change. We have an ESA climate office that is again looking into climate parameters. So we have a huge array of activities within the European Space Agency. About 1/3 of our budget is allocated to Earth observation. Then you go into space debris, and we have heard this very clearly also from our colleagues and friends that space debris obviously is something that we need to look after. Do not understand me wrong. We are not against launching satellites, which eventually will create debris, but what we do, we're supporting this, of course, but what we do, of course, is we need to make sure that space debris or satellites in orbit at the end of their life need to be managed properly to avoid exactly what happens on the shores of Australia and in many other places, that we are seeing them falling down or even disturbing the operations in space. And there we have quite an active program, Zero Debris Charter, to name just one, but many other things as well. And when we go further to the lunar surface or to outer space, again, sustainability is an issue, and we're also looking at this. So it's really a multidimensional activity from your own house to looking at our planet, using satellites and space for sustainability purposes, to making sure that our satellites in space are not hindering others, and therefore we have a sustainable management, and then beyond the Earth orbits into outer space.
Thanks so much, Joseph. So we just heard that there's a big range of priorities. Also, at the same time, the priority it is to have a sustainable use of space. So I think that with all the different points of view, we all are converging that space, it's getting crowded, and we need to make sure how we manage it, right? But also, down on Earth, there's different priorities, and also affects how the environment is affected. So I would like to give the word to you, Albin. Given the first volume of your sustainability strategy, can we say that safeguarding Earth's orbit is NASA's most foremost sustainability priority? And if so, how does its prioritization shape your near-term actions and the global partnerships to make sure that the space is sustainable?
Yes, of course. So just for pretext, NASA has a plan to release a space sustainability strategy in 6 different volumes, the first of which is Earth orbits, and of course that is our approximate and most important one for the time being. You know, as of right now, on October 2nd, 2025, we are primarily, trying to cope with the environment in Earth orbit. And so we've got, when we stood up our division last year, we inherited 6 different programs. The first and probably the most the oldest of the one is the Orbital Debris Program Management Office, and their job is as has been mentioned before, is to limit the generation of debris, making sure that when we dispose of debris, it doesn't do any harm, but also to figure out how to cope with debris. So if it's trackable, can we avoid it? If it's not trackable, can we survive being struck by it? And that's all meant primarily for low Earth orbit, where that's the biggest problem. There's also attached to that is a hypervelocity impact test program out there that goes out and takes debris and fires it at model spacecraft and others out there to figure out what the effects of those impacts are, and also helps with determining when debris disperses from impacts from those pieces out there. And also attribution, when a solar panel falls off a satellite in orbit, can we go back and figure out, was that something that, was it a battery or something like that? Or, and that's the other part is also coming up with things such that you don't turn your one dead satellite into multiple pieces of debris. Most of the debris out there generated is not from impacts or collisions, it's from batteries that run away, it's from fuel tanks that rupture and cause these things to become debris out there in orbit. So we have active programs to promote passivation of these different satellites when they're done. It also turns out that one of the biggest litterers of our orbits around the solar system is the solar system itself. Some of this debris has been around for 4.5 billion years and doesn't seem to have gone away. And so they can still affect us, and we have to cope with that too. Again, an impact from a micrometeoroid can turn our satellite into debris just as quickly as a piece of human-generated debris. So we try and track and characterize those populations to want to avoid them, and also to, again, cope with them if we should wind up having to go fly through those areas, because that's where we're going to operate. Also, now we have the space traffic and everything out there is debris or active payloads out there, and we're seeing that most of what we're dealing with in Earth orbit that we can track right now are large constellations. And so how do we come up with ways to work with them? We've never seen quite this level of density of traffic in the history of operating in space, but we've also never seen the level of technology used to keep these ones from running into each other. We're looking at these thousands of them out there, but we don't have any even really close calls in recently because they're able to use machine-to-machine and automated systems out there, whereas it might have taken hours or days to come up with a solution for how to avoid one another. They're doing it in near real time. And I was approached by one of the large constellation operators going, hey, you're talking with the folks from Starlink. Is there any way we can have just a common venue out there where we can all talk and work those pieces out there? And I think that is going to be key to how we're going to cope with that. When you can communicate and do things dynamically, suddenly that space becomes a whole lot bigger again, and it gives us time. It makes us worry about the density out there. But again, if we can have more certainty about where they are and where they're going, we can operate closely. And we see it on highways every day. And so that's one thing we're worried about there. So that's Earth orbit, and we're also concerned about just other space phenomena out there, solar flares and plasma and things like that can tell us that where some of the things that we cannot see in terms of debris, the plasma out there can give us trails or give us hints to where they might be as well. But we can also be turned into space junk by being impinged upon by solar events and other space weather. So we watch that as well. We don't have the capacity to control it yet. We'd like to do that, but that's a long way off. And again, everything we're learning now, how to export that to where NASA's operating. NASA operates at the moon. NASA operates out of the James Webb Space Telescope 1 million miles from Earth, where solar weather dominates, and so does the natural debris out there. We're operating in Mars orbit right now, and we plan on proliferating more so out at the moon and Mars and on the surface of those planets out there. What are those implications out there where places that don't have atmospheres that can naturally gobble up debris on its way down? Everything that deorbits above the moon is guaranteed to hit the lunar surface. Nothing's going to burn up. Mars, somewhere in between. More things will than they do on Earth, but certainly that it does have an atmosphere. These are things that concern us. How do we work those things into our debris strategies out there as we come up with our next volume, which is going to be Moon and Mars, because they're part of a continuous campaign of exploration out there. And we're trying to incorporate what lessons do we take with us out to those areas, and what things are unique to those areas that we need to consider.
Oh, thanks so much. Jane, Philippines has the chance to design its program with sustainability in mind from the beginning. What are the priorities guiding the development of the space activities and works with regional partners to ensure a long-term and also responsible access to space?
PhilSA is a relatively young agency. We just turned 6 this year. So with an infant space ecosystem in the Philippines, PhilSA is doing a lot of heavy lifting. But being a new kid on the block also presents some advantages. For one, we don't need to start doing things from scratch. We leverage from the experiences and lessons learned of more advanced spacefaring nations. Value creation has always been at the core of our mission. So we strive to create and add value at each component of the space value chain, from the upstream to downstream, and up until the socioeconomic impacts from space have been realized. So we did a decadal survey to identify our priority challenges and objectives. We scan what's already available in terms of existing and future satellite missions. From there, it helps us determine the gaps and priorities for future sovereign satellites, and more importantly, ensure that we are maximizing the use of what's already out there. So to cite an example, currently we are developing a new satellite. It's called Multispectral Unit for Land Assessment, which is scheduled to be launched next year. It will serve primarily applications for agriculture. But in the meantime, we are working with partners. A notable example is with the European Space Agency through the National Copernicus Capacity Support Action Program, where we access the Copernicus Sentinel data. So we are now co-developing workflows for 3 pilot services, which includes crop mapping and land cover mapping, among others. So at the regional level in ASEAN, we also recognize that space sustainability is important and that there is a need to develop a regional capability on space situational awareness. The Philippines is currently co-leading this effort together with Thailand under the ASEAN Subcommittee on Space Technology and Applications. So our goals are to enhance data sharing, build regional capacity for monitoring the orbital environment, and promote responsible space traffic management. So I can say sustainability thrives on cooperation. Though we use space primarily to serve our domestic needs, in the long term, ensuring continued access to space is a shared responsibility.
Thanks so much. Joseph, ESA has a holistic approach to space sustainability. It's rather unique. We're aiming to minimize the impact of our activities in 3 different environments that we interact, on Earth, on orbits, and beyond. How is ESA embedding sustainability into our mission planning and procurement?
Well, thank you, Roberto. As you say that, you're right, I think, to say that ESA is quite unique in the approach that was taken, because sustainability really goes across the various phases and the various activities. I mentioned before that we have measures in-house, then our satellites are measuring the sustainability on our planet and of our planet altogether, and then going further. But of course, we do this through a number of actions, and this is really when we define a mission. There's a number of criteria defined in order to meet sustainability criteria. Let me just pick out one. I mentioned the Zero Debris Charter, which is something that is actually quite unique. We have offered on a voluntary basis a document or charter for members, and these members are either countries or industry or organizations. If they sign up, they commit that they will take out a satellite at the end of its life from orbit within a period of 5 years. And I've instructed my engineers within ESA to implement this, obviously very strictly. That means every engineer in ESA who is developing a new satellite, and we have launched quite a few recently, and we keep launching them, has to guarantee that at the end of the life, the satellite will leave orbit. That means there's enough fuel on board to deorbit it. The structure has to be made in a way that it is breaking up and burning up completely in the atmosphere, not washing up at the shores of Australia or coming down to the surface. So there are a number of measures that we are doing. Of course, we need to develop technology in order to make this happen. That means technology for the deorbiting, for the structures. Some of the smaller satellites, CubeSats or smaller satellites, they don't have a lot of money, so they need very simple mechanisms of doing it. And one of our technology studies that we have done and which we will implement on satellites is at the end of the life, some kind of spring opens a panel, a solar panel. It's like a sail, and although there is vacuum, there's still a little bit of drag, and this drag is then making sure that the satellite can be taken out of the orbit and therefore deorbits and is leaving the orbit space in order to not create new debris. So there's a lot of measures we are taking. Actually, I want to invite all countries, organizations to sign up to the charter. We have 180 members today who have signed up to this charter, also including in the Southeast Asian and Pacific region. New Zealand is one of the countries that has signed up, and we are in discussion with several other countries. So it's really a very popular mechanism. And the nice thing is it is voluntary. We are not a regulatory body as ESA, we are a space agency, but we have just put the initiative in place, and many countries say, look, this is a great idea, let's join this charter and this group, because it is really a very concrete measure of implementing sustainability, as some of you have mentioned how important this is. Maybe just one second point for you, Heriberto, and also for the audience here. On sustainability, also, of course, on climate change, we are doing a lot through our Copernicus program. We have many measures in place in order to, first of all, monitor the planet, but not only that, also convert data into simulations. We have just implemented a high-performance computer to merge observations with Earth system models and high-performance computing in order to allow simulations, what we call digital twin Earth, that we can simulate our Earth or parts of our planet in order to see what would happen if this change happens, if temperature increases by not 1.5 degrees, but by 3 degrees or 2 degrees. What happens if the tropical forest is deforested in the Amazons, for example, by another 10%? What is the impact on not only the climate, but also on people, on sea level rise, on the economy of people, and so on? So this is quite a complex activity, but also to show that we use all our space means and deep tech and high-tech technologies in order to make sure that we help people on the ground with their local issues which they may have.
Thanks so much, Joseph. Enrico, we all know Australia, it is in a very unique position. It is very far. I think the closest flight was the New Zealanders, that was 4 hours. Everybody else were above 7. But that also gives you a very unique location and also a unique cultural aspect that it has to be handled. And with that in mind, what is Australia's space sustainability approach?
I think Jane ended her last answer very well in terms of the cooperation needed internationally. This is a global problem. It needs a global response, and Australia is committed to working with all nations to ensure we have the right rules and norms of behaviour. We're a founding member of COPIUS, a signatory to all the space treaties, a founding member of the Artemis Accords, and so we want to ensure at the multilateral level we're doing what we can to promote the right rules and norms of behaviour, because the impacts of space debris, the impacts of to dark and quiet skies are disproportionate to activity conducted by nations. And so that's why we've got to bring it to that fora. We've also made pledges to not conduct direct descent anti-satellite kinetic tests, for example, as part of those encouraging those rules and norms, and are fully behind the long-term sustainability guidelines of UN COPIUS. So I'd say at the top level is the respected moderate voice we have in those fora, and we'll continue to do that. And we put forward the Dark and Quiet Skies agenda with our partners, particularly for the cultural and astronomy aspects. The second part is regulation. We are a regulator as an agency, and that's similar to, I think, New Zealand Space Agency and InSpace. So Australia is still a relatively small player, but growing, and over the next decade we'll see many more Australian objects on orbit. So how do we ensure we don't exacerbate problems? So we have debris mitigation rules and guidelines in our regulation, and we'll continue to refine them. But then there's the balance to regulation, and that's what we do for capability building. So through our various grant programs, we've invested in some innovative ground-based space situational awareness technology, such as passive radar, coming from our astronomy background, through to on-orbit SSA, and you may see one of the cameras from HEO at our stand. And so we can use that geography the other way to help characterise that environment, and we have some wonderful scientists at our university, I think, that are becoming world experts on debris re-entry and characterisation with things such as the Desert Fireball Network. So we want to lead the world in helping better predict. You know, it's very hard. The science is still developing because of disturbances in the atmosphere and vehicles tumbling. You can't predict with precision unless it's a controlled re-entry where these things may land. And so we want to contribute in capability building as a way to improve for the future. So I think sort of multilateral at the top, we do things through regulation and we do things through capability building. And I think on the cultural aspect, you know, we really focused this through this IAC as well with the First Nations presence.
Thanks so much. Before I open the floor for questions, we have heard about your national drivers and regional solutions, but looking forward, global cooperation will be essential. The orbits are all around it. We have heard that a launch in French Guiana or in Cape Canaveral will affect Australia or the Philippines, so this is something important. But where do you see the biggest gaps? Because we have technology, regulation, or governments, and could they be bridged through international partnerships? I will start with you, Albin.
Okay, so data sharing and sharing data in a dynamic and real-time manner is probably one of the bigger gaps that I see working with right now. Although we're making progress, for years, for political and legal reasons, our ability to communicate with the Chinese National Space Agency has been extremely crude. Emails and drop boxes, and maybe people reply. And for years, if we had a conjunction, we would send a note to the Chinese saying that we we think we're going to run into you. You hold still, we'll maneuver around you. And we often just would not get a reply. And in one case, because we never know if it got it, we did maneuver both at the same time and unfortunately missed. We've come a long way on that. In fact, just yesterday, we did a bit of a celebration because for the first time, the Chinese National Space Agency reached out to us and says, we see a conjunction amongst our satellites. We recommend you hold still, we'll do the maneuver. And that's the first time that's ever happened. And so, holy cow, how long have we been operating in space? And this is the first time we're actually getting two-way communications between two of our more prolific space operators out there. I'd say the next biggest challenge is the technology we're using for space situation awareness, again, is also crude to the point of primitive. These are, our space situational awareness network that we have out there, space surveillance network, as capable as it is left over from Cold War products out there. The Cold War ended back in 1989. Okay, and so we're still using the types of radars out there that were meant mainly to track ballistic missiles coming over the poles. So we're not geographically optimized for all the different orbits that are out there, especially around the equator. When you get there, you're limited to the limitations of radar in terms of measuring speed, in terms of measuring position and uncertainty out there. So you can have an object out there the size of a school bus, but the uncertainty bubble around it is the size of Manhattan Island. It's just a couple of orders of magnitude too big. So, and you're trying hard to keep these little bubbles of uncertainty from clipping each other. So we risk either doing a lot of unnecessary maneuvers, or we risk having two satellites run into each other, and that puts a huge operational burden on people up in space. If you could shrink that uncertainty bubble down a couple of orders of magnitude, suddenly space gets a lot bigger again. Suddenly we see things are going to miss each other by a few hundred meters, and nobody gets of great concern. But a few hundred meters of miss distance right now is cause for near panic at this point, because we don't have the technology to go scry out whether or not that's going to result in a collision or not. And then for us at NASA, it only gets worse because we've got lots of radars, lots of telescopes here on Earth. Right now, we are trying to keep things from running into each other at the moon. There are 3 satellites in the same orbit above the moon right now. It turns out everybody likes 100 kilometers of altitude in a polar orbit above the north and south poles. And so they tend to go to those spots out there. Well, right now, they're all cooperating. They're telling us where they are. And from that, we're able to determine through our MADCAP program at the Jet Propulsion Laboratory when there's going to be conjunctions out there and they can maneuver. But if any one of those satellites goes dead, or if there's a natural object up there like a rock, we have no way of tracking that. So we need more prolific sensors. We need more capable sensors. We just need all-around better situational awareness. You cannot hope to control or improve an environment if you don't understand what it's doing to you in real time.
Well, thanks, Albin. Well, I'm surprised that we get engineers that are younger than the technology they're using. Joseph, the same question. Where do we see the biggest gaps, technology, regulation, or governance?
It's probably all of the above. Certainly regulation is one point. I mean, sometimes I compare what happens in the evolution of space with what happened 100 years ago in the evolution of planes and air traffic. 100 years ago, when the first planes were flying in the sky, of course, everyone was flying as they wished, more or less, and there were very little rules, and you could go from one place to the other. Today, we have a very clear air traffic management system with very clear rules on which planes are flying on which altitude and how to avoid collisions, obviously. In space, we are actually in a similar situation. Of course, we have more and more spacecraft coming into space, more than 10,000 today, and the numbers are going up very fast. So we need just to do the same as people have done 100 years ago, or several decades ago, in establishing not only an air traffic management system and international organizations that look after it and make the rules, and then others who are observing the rules, but in space we need to do exactly the same. So we need governance. As you mentioned, whether governance is needed, absolutely, because space by nature is global, and the issues are of global impact. Secondly, we need technology to monitor it and to manage it, and space traffic management systems. That means a combination of ground radars, maybe space-based systems that allow to know where which object is, not only the satellites, but also debris and maybe unused upper stages of rockets, which are still also a very big problem, by the way. It's not only satellites. satellites. And all this needs to be organized. So yes, we are, I would say, in a phase where the problem is recognized. That's also the reason why we have this discussion here, and thank you for organizing it. But now we need to make sure that we are not behind the reality. That means the reality is kicking in so fast, launches are going so fast, so many satellites are coming up in a very rapid number, and others, and the means and the regulatory and the technical means are not catching up. And I think there's a lot of work to be done. And this is exactly also where ESA is working on several of these activities, not on the regulatory aspects, but more on the technical sides. And I think this needs global efforts. This needs everyone to work together, from China, the US, Russia, Europe, Africa, Philippines. Everyone is needed there to really work together because it's affecting everyone and is for everyone's benefit. So yes, this is really a call for global action, which is urgently needed in order to really make good progress on this domain.
Thanks, Joseph. Enrico, from the Australian side, same question.
Yeah, I mean, I think it's all been said, so I don't want to repeat the good answers from our colleagues. I just one observation. We endeavoured to bring quite a bring Pacific delegation here, and obviously we have a Pacific Space Agency here, but we wanted to focus also on Pacific Island nations. And yesterday we had a meeting with a couple of ministers from the Solomon Islands and the Cook Islands, and also officials from Fiji, Tuvalu, and Tonga. And what was interesting was a transparency question. So if you're not a space, we generally in this room, I think, have a good understanding of orbital mechanics, and actually the probability of a piece of debris even today hitting a particular country, or not country, but a person, is low, right? Because of just, things burn up, and a lot of the planet is covered. But if you're a nation that hasn't interacted with satellites or understands orbital mechanics, you'll think the sky is raining down with debris. We hear about congestion. So there's a level of transparency that many nations don't understand what the actual risk is. So I think that goes to Alvin's point around data sharing. There's an element of sharing all the benefits we get from space and what are the risks, how is the global community managing them. So that was interesting perspective in the questions that we were getting in the round table.
Thanks so much. Jane, to close.
So in terms of space governance, I think it's high time that we get policy directions at the highest level of government. Next year, as Philippines serves as chair of the ASEAN, PhilSA is working towards getting the heads of states or ministers issue or sign an ASEAN declaration on sustainable space science, technology, and innovation, recognizing the value of regional cooperation in addressing common challenges through sustainable and peaceful uses of space. So in the Philippines, our chance to grow as a spacefaring nation lie on building partnerships, sharing capabilities, and ensuring that every step we take also strengthens the resilience of the entire region.
Thanks so much, Jane. So now we get a couple of questions from the public here. I have one for all of you. How do you see the role of private space sector in sustainability?
Let's start. Yeah. No, the private sector will play a hugely increasing role. Already today, the private sector is providing services, and I really talk of all the elements of sustainability. It's not only debris monitoring, and which is obviously the one that we have been focusing here. It's also on sustainability, using space technology for sustainability on Earth. There's so much to do to make sure that our planet is used sustainably, that not only our generation is having a nice planet, but also the next and the next afterwards is really having an environment that is good and with all the elements that are related to it. So the private sector is really increasing its contribution. I'm very happy to see that. We are supporting this enormously in Europe through the European Space Agency. We have programs put in place where we attract venture capital funds to public funding of the European Space Agency. Last year we got 1.5 billion of private funding coming into space in Europe, a 53% increase compared to the year before. And certainly the private sector is the one that we would like to utilize more and more for all aspects of space, and obviously sustainability being a big issue.
Thanks, Joseph. Somebody else wants to talk?
Sure. I think Joseph's done a good job of describing the private sector as being a supply end of that space sustainability economy. but there's also the folks who are on the demand or receiving end of that as well. And I think if you see the large constellations that are going up, they suddenly have a stake in this. What you see was not the regulations or anybody else who's driving them to some of their sustainability or responsible practices. It's their own business models and interests. Now, if you're trying to keep several thousand satellites in a shell and you have a certain number of them that don't come out and turn out, pretty soon you've clogged up that orbital shell to where it's no longer useful for your own business. And so because they've had to go deal with this problem, they are coming up with innovation in ways, like you said, things that we can export to other places. We're learning now from our private sectors right now as they're innovating unique and really cost-efficient ways to operate sustainably in orbital shells right now. And I don't think we're done learning from that.
Thank you.
Yes, just to add quickly, we think the private sector has tremendous role in keeping space sustainable. Particularly on the downstream side, the solutions and services are better delivered and I guess well understood by the private sector. So we rely on them to come up with customized, tailor-fitted, and real-world solutions that benefit everyone. So in the Philippines, we are doing a study, actually a roadmap on space industry development. And we hope that with this roadmap, we will be able to encourage the domestic space industry and the private sector to take part and contribute to developing our domestic space economy, keeping in mind, keep making space sustainable. Yeah.
Thank you.
I think it's been said by panelists, but incredibly important. We have a commercially led ecosystem here in many ways. The supply side, the innovation in sensors, the data integration, which is actually more important now than maybe adding more sensors. How do we integrate this data into automated decision making? But also innovation, right? Many entrepreneurs are born by outrage. When people are outraged by something or don't like the status quo, that can spur an entrepreneur to develop a business to go tackle some of these problems. So I think we should rely on that entrepreneurialism to help. And we've got companies, small startup, not ours, but in Australia, Paladin Space, who actually has some innovative approaches to collecting debris on orbit. And so I know I believe in that spirit of entrepreneurialism and being outraged or using outrage to innovate and create businesses that do good.
Perfect. Thanks so much. I'm going to go one personal question. Jane, they say that as a student, I feel that the impact of collaboration between Asian countries in the space sector is still not strong enough. How does the Philippines plans to strengthen collaboration in the space sector within the region?
Thank you for that question. It's unfortunate that that's the feeling, but yes, we are working closely with our fellow ASEAN member states. I mentioned earlier a platform in ASEAN, the Subcommittee on Space Technology Applications. It's SCOSA. We meet regularly. We have projects, initiatives across different priority areas. And I guess I'll cite an example happening very soon. The Philippines is hosting the Asia-Pacific Regional Space Agency Forum, or APRSAF, together with JAXA, of course. And this presents another opportunity to bring nations in our region, talk about their programs, see how we can complement each other, find solutions, maybe for the future, even look at joint missions, regional satellite missions, for example, capacity building programs. So there are several avenues that we are currently doing. To the student who asked the question, approach me later. I'll be happy to discuss these details and opportunities with you. But yes, we have these efforts towards fostering stronger regional cooperation.
Thank you. Albin, you mentioned 6 tomes of sustainability. We only have the first volume published. People want a little bit of spoilers. They're saying, what's the status of the later volumes of NASA Space Sustainability Strategy, and what will they cover, and when will they be released?
Well, that's all in flux right now. We are awaiting further guidance from our new administration. Initially, one of our Mars and the Moon were going to be 2 separate volumes, so you've already got the 2. So I guess we've gone from 6 down to 5. But we'll wait and see what comes from the guidance on that one. And so not to give you a non-answer, but the crystal ball is hazy on that one right now.
Okay, perfect. So stay tuned. Thank you. Joseph, this question I think you're going to like. Could the ESA Zero Debris Charters be an equivalent to Artemis Accords for space sustainability?
Thank you. I really like the questions, whoever was asking for it. No, I think it is quite an interesting vehicle. And maybe one thing that is very interesting on this Space Zero Debris Charter is that it is really a different mix of participants who have signed up to it. I mentioned the countries, mentioned quite a few of them, but about 3/4 of them are companies, private companies who have signed up because they have a very genuine interest that if they build satellites and launch satellites, that their satellites obviously are also being taken out at the end of their life, assuming that others do the same, and therefore really are creating this environment and this behavior that space is utilized in a sustainable manner. And actually there are quite a few large companies who have signed up to this as well, who are building up huge constellations. Obviously in Europe we have our big industrial partners, Airbus, Thales, OHB, who have signed up to the charter for very obvious reasons. They said to me, look, Joseph, it costs me money to implement the measures to deorbit the satellite at the end of its life. I need more fuel, I need to maybe change something on the design of the satellite. It costs me money. But of course we are needing to do it, otherwise we are eliminating our future ground of business. That means space where the satellites are being launched. But also, for example, Amazon was signing up to the charter in view of the future Kuiper constellation, which will be thousands or tens of thousands of satellites that are coming up. So to say that also they, as a larger partner globally, are having a keen interest, and the charter keeps evolving. Actually, I would like to acknowledge the presence of some of my colleagues here in the room. Rolf Densing, the director in charge of operations, including space safety, is here with us, and certainly can give you more information on the future projects of this of the evolution of the charter. Will it become the future Artemis? Artemis, of course, is driven more on a government-to-government level, but the charter is a mix of government and businesses, which I think incorporates the partners that need to be on board.
Thanks, Joseph. Now, I'm going to merge 2 questions because they're very similar, but I think that it is very related to what you're doing here, Enrico. They're saying that there's any practical frameworks to be following in designing satellites to make sure that they minimize the impact of dark and quiet skies, and it also how space agencies can address the conflict between light pollution from satellites and astronomical observations.
Yeah, no, terrific question. And as I said, something that's important Australia has been advocating with partners in COPIUS, particularly from the astronomy and cultural aspects. I mean, we have debris mitigation guidelines in our regulations in Australia, and we are looking at, as future evolution, what are the things that can be done for both the dark and the radio quietness. I mean, there's the, obviously, satellites have solar panels for a reason, and they're going to reflect light. So there's a challenge sometimes, but there are things you can do with surfaces. We don't regulate that now, but I mean some of the mega constellations have made improvements versus some of the earlier designs. That's encouraging, and we encourage all operators to be doing that. And then the radio quiet one's actually hard too, and we've got some representatives from our Communications Media Authority of the Australian Government in the room. Spectrum leakage is a real challenge with maybe transponder. I mean, you never get a perfect frequency signal, and when you've got so many assets, you almost get a wideband noise, in many ways. And so I think that's something. The spectrum license is regulated often by countries and awarded, but it's hard to sort of, once the objects on orbit, to really control, that spectrum leakage. And so we haven't solved that, and we haven't regulated necessarily specifically for that. So I think these are frameworks we need to develop. So I can't offer we have those frameworks today. But again, going back to the multilateral piece, Australia just ticked over 50 objects on orbit. So we're registered objects. So we're still a relatively small player that will grow quickly. So the mass, we have to work with the global community to do this at a much bigger scale than what we're currently contributing.
Perfect, thank you. We get 5 minutes, so I'm going to ask one question for all of you, and if we get more time, maybe another one. But in conducting space activities, there are often unintended consequences of what we do. Some are positive, however, some are negatives. What consideration is given to those consequences, if any, and how do you navigate that? Somebody wants to start?
Very good question, and really thank you for that. Sometimes I use the example of, or if I get a question from journalists or somebody to say, look, your rockets are polluting, and how can you justify that? You're increasing the carbon emissions and so on. Yes, it's true, of course, every means of transport is polluting, airplanes, cars, rockets, and so on. But I usually say, look at what they are doing. If this rocket is transporting a satellite that is monitoring our planet, take a Copernicus satellite as an example, first of all, without satellites, we would not understand the state of our planet, as simple as that, because the accuracy of the data we are getting of the atmosphere, of the oceans, of the land, the interactions of the Earth system is so perfect, is so well documented with these observations from satellites, so that we really understand issues like climate change, like sustainability, sustainable use of farmland, sustainable use of water management areas, and so on. So we do need this information in order to, first of all, understand the magnitude of the problem and therefore give policymakers and decision makers actions or proposals for actions that they can act upon and really implement some measures. So yes, the rocket is polluting, that's correct, but the benefit of these satellites providing the information that we need in order to make better decisions at the end of the day is so much bigger, so you really have to see it in relation.
Thank you. Somebody else wants to add something?
It's a very good answer from Joseph. I mean, it's a risk and reward, and the reward is very high, and our societies depend on it, and that's why maintaining access to space, maintaining an orbital environment for future generations is critical.
One of our former directors at NASA used to always fond of telling me that in any large program, the most important mistakes are made on the first day. There's just ways you just can't anticipate how the world is going to turn out. You think about the internet when it was designed back in 1969. Nobody ever thought about hacking or just weaponization of information once you had that out there, and did not put in the basic protocols that would allow you to protect for the things that we've had to scab those things on as time has gone on. We were back in 1957, nobody thought about the fact that space might ever become crowded. This is this vast new ocean out there. There's oftentimes out there where we start off with the best of intentions but can't see that. I think it's always keen to make sure that we keep the original intents in mind and making sure that the goals are, because you're always going to run up against that. And I think you just have to be able to have a certain amount of humility when you approach something, a little bit of, I call skeptical optimism. What if I'm wrong? What if I'm exactly dead wrong? And not to be so immobile in your thoughts that you can't think about, what are the hedges if I've got this slightly off? Another saying was that there's 100% right. We don't have this 100% chance that this is not 100% correct. And so you think about that. And so it's having the imagination to be able to try and think about not necessarily everything that could go wrong, but how you would react to things that might be that you can steer yourself back, and keeping your original intent while you're doing that. Don't get lost in just the gyrations of reacting to this particular crisis.
Thank you.
Yeah, and just to add to what Alvin said, in navigating the challenges associated with space activity, I think transparency is very important, and we enjoin everyone to be part of the solution.
Thank you so much. We have still 1 more minute. I would like to add something, because we're talking about sustainability, and it's always thinking about the future, how we ensure that the future generations are able to use space. And there was a question actually last minute that says, how do you involve young people, especially students, in your space sustainability projects?
I will be fast, but I'm very happy about this question, because that's something that is very dear to my heart. I am involving young people a lot in defining it, and actually it's those young people who tell me that you have to look after this, you have to do that in terms of sustainability. So it's a very important impulse which I get there. The energy of young people is incredible. I actually then turn it back to them and say, look, I challenge you as well. You tell me sustainability is important, we should do something. Tell me what we can do, how we can do it, and come with concrete project ideas. This is happening within ESA. We have a very active young professional group in ESA, and they love talking about this and come back to us, to the top management with some ideas. So fantastic. I really like this energy, and I see also in this room quite a few young people. I'm very happy to see that, and please come back with your ideas and bring them to whoever needs to listen and to hear about, and hopefully we can do something about what you have in mind.
We have a children's book. It's called Tala and Her Journey to Space, and it's not just an ordinary children's book that talks about planets or the solar system. Instead, it talks about peaceful uses of space and responsible behavior in space. It talks about the 5 UN treaties. And we have that book in Tagalog, an English version, and we are very happy to work with UNUSA in translating the book into the official languages used in UN.
I got a copy. It's a really good book. You should see it. I think it's like it teaches you how to register an object with the UN. It's like awesome. One of the really quickly, out of time. One of the programs we're really proud of, the agency we sponsored, was called Kids in Space. So this was a 3D printing challenge where there was a teacher element, educating them in various aspects of 3D printing and others, and it was a design challenge, and it wasn't specific. But what was wonderful when I saw the finalists. How many of them went straight to space sustainability, vacuum cleaners in space, and all these like wonderful concepts? And you know one of them will come through at some point. But I think the youth is ahead of us in understanding the problem in many respects. And to what Joseph said, we need to leverage that energy and encourage it.
Thank you. Albin, something?
I won't get started because I would go on for hours. It is one of my bigger labors of love is to going out and inspiring this next generation to bring their fresh ideas to all of our problems out there, because they haven't learned how to stay inside the box.
Perfect. No, thanks so much. With this very optimistic approach, I would like to thank all of our speakers and everybody to being here. Please, a big round of applause to our panelists. Thank you so much.